It's getting to the point where I can just feel that an app is using server components when I use it. Nearly 1-second page navigations. I'm sure it could be improved, but I've yet to come across a server component app in the wild that feels good. It's about to say V0, but I just checked and I'm not even sure they're using them anymore. As per usual, Dax is mostly right, slightly inflammatory, and not showing the whole picture in this particular instance. And I think there's a lot to dive into here. I agree with him that most of the server component apps I have seen have been really, really rough, but I don't agree this is the fault of server components. I'm going to say something a little controversial on this one. I think the blame for the slow server component sites falls less on the Next team, on Vercel, and certainly less on the React team and the people working on server components directly, and more on people like me. In order for this to work and work well, we need to deeply understand how server components behave and what they mean for us as developers. Because there is no excuse for any website to be as slow as this one is. It almost feels like we've gone back in time to the way pages worked before. I want to break down what makes sites like this so slow, how we got here in the first place, and most importantly, how to use server components correctly so that we can have the fastest possible websites while also matching the great DX that we expect from tools like React and Next.js. Sadly, developer experience doesn't pay the bills. I've learned that lesson enough times, so we're going to do a quick word from today's sponsor right before we dive in. Building apps has never been easier thanks to all these AI tools, and deploying them's never been easier too, at least until you need to add a CDN, a DDoS protection layer, file storage, a database, automatic builds during CI and pull requests, and all these other things that we expect now as developers in order to keep moving as fast as our editors let us. That's why today's sponsor, Zavala, has changed the game for all of you guys that need to host real servers. Once I saw this dashboard, I immediately got it, because Zavala makes it so easy to deploy an actual server instance and throw the right infra in front of it. Setting up Cloudflare in order to handle DDoS protection, CDNs, and all of that stuff that you really should be doing in front of your app is particularly annoying, especially if you're using frameworks that are expecting traditional server hosting, like, Elixir, Laravel, Rails, etc. This has made my life significantly easier when deploying things that aren't my usual JS stack. Not that it doesn't work with that stack, it actually works really well with all that stuff too. Where things get way cooler is the pipeline feature, where you can set up preview, dev, and production environments. Plural, yes. So people can file a pull request and automatically spin up a preview app that will sleep after not being used for a while. These workflows are obnoxious to set up, and we had whole teams at Twitch building all of these things so that we could have better code review experience. All of a sudden, it's just a feature built into the platform. And as I said before, it's not just servers, and it's not just the Cloudflare integration. It's so many more things like object storage and databases too. It doesn't matter if you're trying to host a static site, a Next.js app, some crazy stuff in Python, some weird side project you built in Rails 8 years ago. Pretty much everything you'd ever want to ship is going to work on Zavala, and I know that for a fact because this is built by Kinsta, the company that made WordPress actually hostable. Check them out today at soydev.link/Zavala, and you'll get $50 of free credit applied to your account. This video is inspired by a lot of the pushback I'm seeing on server components. Obviously, this in the performance side, that's the most important piece, but also complaints like Michael Jackson from the Remix team saying that server components are nice in theory, but they're not working out. Evan here saying that server components aren't necessarily a problem. They unlock cool patterns, but the overhead is the issue here. And me responding with probably too many words to Dax's post, trying to break down what happened and how we got here. I could just read this to you, and believe me, part of me was tempted to just read this out, considering especially how positive the attention and feedback was to it. But I'd rather go in detail on how we got here and why these apps are so slow. I'm going to do a real brief history of the web. If you want a deeper version of this, I have a long video that I think is genuinely super underappreciated. All the ways HTML gets to your browser. I think this is one of my best videos, even if I don't look like that anymore. If you want a deep dive on all of this, check that out. Going to do an overview and then focus more on how to do this stuff better. The way the web used to work was pretty simple. The user sends a request to the server for site.com/index.html, and then the server processes that request and sends a response, which is the HTML content. This is hopefully something we all understand. Once this HTML goes back, it will have link tags in it, which are the primary method of interaction. It might also have forms. And whenever you fill out a form and hit submit, or you click a link, it sends a new request to the server, either requesting new HTML, so site.com/new.html, or it will do a post request to a given URL, usually the one it's on with traditional form data, where it will post to site.com some form data, and then the server gets that data and it again responds with new HTML. This is how all interactions worked. There are some important catches here, though. There is a big delay from when a user clicks on something or does something and when they see a response on the browser, because the server is what controls what's in the browser, not the browser, not the JavaScript, none of those layers. When you do something in the browser, you have to wait for the server to respond with the updated HTML. The only way the content of your page changed at this time was either you sent something to the server and waited for new HTML, or you used a marquee. So you had text that scrolled around. But that was effectively it. Over time, web apps got more and more interactive, in particular with JavaScript getting more and more popular. We had the weird Flash and Java era. I'm not going to go too deep in those right now. The thing I want to focus on is more app-like behaviors in the browser, which eventually led to what we now affectionately refer to as single-page apps, SPAs. The big difference with SPAs is that the user only requests HTML once. So the user can go to literally any page. So unlike previously where the URL mattered, because I would go to site.com/index or /user-info, none of that matters. So literally mentally block out whatever comes after the domain, because it doesn't matter in this case. The reason it doesn't matter is because the server only has one page to send. That's what single page app means. Sends only HTML. This HTML page that is being sent from the server or from a CDN or something else has some things in it that are important. This HTML has a head tag. This head tag has the things that actually matter. The one that we care about is the script, actual app.js. This is what most React apps roughly look like HTML-wise. There is no actual content in the body. They might have bothered with a real loading state. Most don't, because the thing that matters is this head tag in the JavaScript. This single page is what's served by all the URLs on your site. When a bot crawls your site, or a user goes to a page, or someone types in a URL, all of those things are going to resolve to the exact same tag, to the exact same HTML. If you go to any page on Twitch, any page on Excalibur, any page on most React apps, it's the exact same content. This kind of sucks because it means when the user gets back the HTML, they get an empty state. It has to run the JavaScript code. The JavaScript code will then make its own additional requests. I'm going to make one subtle change here, which is instead of calling the server, I'm going to call it CDN. The user will then, after they've loaded that HTML, request app.js or whatever else they need to run the page. The CDN will send that back. And now the user can run all of that. And more importantly, they can start generating the actual page content. So once that has all happened, God, I wish I didn't bind all of these because now it's going to be annoying to stretch this. Cool. You get the idea. User requests from a CDN the site. They get back the static HTML file, which has the tag for the JS in it, CSS, and all those other things too. They get back that code. They run it. And now they need to get some data from the API. So we have a separate thing here, which is the actual server. Not the CDN. CDNs are only holding static content. This is the actual server that does the actual work. So the user has to go to, I don't know, /API/some data. And then the server parses their credentials, checks who they are, figures out what they're requesting, and then responds with whatever the hell they were asking for. In this case, probably going to respond with some JSON. Data, you get the idea. Now your app has that data. Now your app can turn that into the React components and eventually the HTML that appears on your page. There's an important question though. What's going on right there? In between this section, once you get the HTML and once the data is being requested and then eventually is being shown to the user. But more importantly, basically from here to here, what is going on? The reason I ask about this section is it's actually a thing single page apps do really well. If your components need to request data, you can do that in the component, which means in that same component, you can render a loading state. That is nice because now when data is loading, the user still sees something on the page and the developer has control of it. It comes at the cost of you can't choose what they see from here to here. You can give them some static HTML, but no one ever bothers. But once the JS is loaded, you have full control of this loading state. And what's even cooler is since every page has the same HTML, most of them have the same JS, and you can prefetch the JS that's page specific if you choose to. Now when a user clicks on a different page, you don't have to wait for the server to respond because a single page app doesn't do server-side navigation. It does it all on client. When a user clicks on a link in a single page app, it doesn't have to make a request to the server. I almost want to make a quick demo to show this, but you could imagine you have a traditional website that has 3 HTML pages. You open up the network tab, you go from page 1 to page 2, you'll see it going to the server to request that page. If you're doing a single page app, it hijacks the routing and the history in the app. And now what it does instead is when you click a link, it uses the JavaScript from the React bundle to update the HTML instead. No longer do you need to do a server request on every single navigation. That said, most pages are going to need to make API calls. When I go from a tweet on my homepage on Twitter to my profile, data has to be loaded to show my profile correctly. Traditionally, that would be a whole new HTML page being sent, and when you're waiting, you would get a loading state from the browser, if even. The browser's loading states, generally speaking, kind of suck and users don't expect them. We'll come back to that in a bit, don't worry. This is positives and negatives. The cool thing here, which is, again, the important piece I want to emphasize is, once this JS here loads, once you have successfully gotten this JavaScript into the client, from that point forward, everything is going to feel immediate, simply because when a user clicks on something, the response happens instantaneously because it's happening on their device. It's not waiting for a server to make that change. In the old model, that wasn't the case. Anything the user did would require a server call. With single-page apps, it doesn't. It takes longer overall for the user to see the right content, but when you feel the page change instantly, it feels faster. And I'm not the only one who thinks this. This is a very well-studied phenomena. If you have a website that takes 1 second to go from load, like the user requested the page, user clicks link, and then 1 second later, you have the full content. This isn't necessarily bad. If this takes 1 second to do, you're not necessarily building a website that feels awful. I know this doesn't feel that bad because I've built websites where the time for loading full content is more than 3 seconds. Some are like 5 or 6, but it doesn't feel that bad because I would respond as soon as the user clicks. So within a very, very small number of milliseconds, I'm going to kill that and instead put one here, which is like 0.013s. At this point here, really, really early on, I changed the content of the page. One more important detail of this is wherever the user clicked, you need things to change there as quickly as reasonably possible. When a user clicks on a link, ideally, you should be able to show on the link and the page that something is happening as soon as they click, because otherwise they're not going to be sure. They're going to click it multiple times. They're going to do a lot of other things. I'm not saying throw loading spinners everywhere. I'm saying that the point of interaction needs to change. If you have a sidebar that has a whole bunch of links in it, something like this, you have like link 1, link 2, and link 3. You're on link 1, you've already loaded that page, and you click link 2. If your loading state is just here, it's better than the weird little bar in the browser, but you clicked right there. So you need to show on that the click applied and something is happening. If you don't, it will still feel slow. This is the case on a lot of websites that are built this way. And for better or worse, sad to say, but this is the case for a lot of sites using technologies like Laravel and Rails that aren't taking advantage of single-page app behaviors. There are exceptions. In particular, if you're using inertia with Laravel, your site's going to feel great because Laravel with inertia is literally using React or Vue as the runtime on the client side. Laravel has now been relegated to server duty. This is how things like the whole Laravel cloud platform are being built. And the reason they feel so good is because they're using React for its strengths, which is the client-side behaviors. And you can handle all your API stuff in the Laravel side or whatever other language you want to use. That does touch on one other important piece here, which is that there's a clear line here, a division between the client and the server. And instead of the server telling the site what to render and what to show, JavaScript devs can handle all of that themselves. All of the dynamic behaviors, all the interactions, all the everything happens in the JS bundle now, not in the server code, which is allowed for JS devs to kind of lock in on that client side and not leave, which has benefits, but it also has some negatives we're going to get to. Back to this loading thing here, though. Before we had single-page apps, you wouldn't have this immediate indication. You might have your site set up in a way where it blank pages immediately when you click the next site, but most didn't. Most browsers would hang on the page you were on as you wait for the next one to load, with no good indication that this transformation or this change is happening. Somebody said that you can use view transitions with help with full page reloads if the page is already loaded, but a view transition doesn't help if the new page isn't there yet. A page transition takes new HTML and old HTML, diffs them, and makes an elegant transform from one state to another. But if you haven't loaded the full content yet, a view transition can't help you at all. The thing that matters here, and it's really important, is that you get the user feedback as quickly as possible. There are some measures of how quick before a user feels like it might be slow. Less than 50 milliseconds feels really fast. Generally speaking, if you can show the user something happening in less than 50 milliseconds, it feels really fast. If it takes more than 150 milliseconds, it feels unresponsive. If it takes more than like 1/7 of a second to see something happened, our brain just assumes the site isn't responding well. There's a bunch of research that gets these numbers. I don't feel like finding it and citing it. Take my word for it or don't. If you use a website where these things don't happen, you'll understand. And if you use T3 chat and then compare it to our competition, you'll understand even more so. And they're also doing this. They're doing things to get you a response immediately. So when you click a thread on the sidebar, it immediately indicates there that you're navigating. Hopefully, I've driven the point home here. Single page apps make it way easier to respond immediately to a user interaction. And when users are interacting more, they're clicking more buttons, they're changing pages more often, they're exploring the site in a different way than how we used to in the past, where we would load a page, stay on it for a while, then click a button and go to the next page. SPAs work differently, and they're meant to feel more like apps, not sites. And that's a big, big difference I don't think people appreciate. The reason apps on the web have gotten so good isn't because servers are fast, it's not because browsers are better. These things all help. The main reason is because single page apps as a paradigm allow for better app-like experiences in the browser. Remember, I said this is going to be a short overview, so much for that part. So where does server components come in with all of this? Server components are very interesting. There was another stage that you're going to have to go to my HTML video if you want to learn more about, which was the idea that a different URL could have different HTML that was just the React code run on the server once to generate a better page as a starting point. Server components go a bit further. I just took the same diagram. This part matters again. The /user info or whatever URL you're going to matters again because it will generate different content. It will check the CDN first to see if there is a cached version of this page, if it's a static page. If there is, it will send static page. But if the page isn't static and it can't do that, it will then forward it over to the actual server. So this then sends to the server. The server will generate the page, and then that generated page gets sent down to the user. This is a very different paradigm. It's also worth noting that you need a CDN that's smart enough to do this two-step layering where it uses the cached asset if it can, or it goes to the server if it can't. And if you're just hosting a server component-based Next.js app on Docker, it's going to have much worse performance characteristics than a single-page app simply because you're not using a CDN. If you're building a single-page app, then when you run your build command, it generates one HTML file and a handful of other assets, and then it dumps all of those into a place where you can access them really quickly that is static. And then when a user navigates, it hits that. But when they call the API, it'll instead hit their server. If you're using server components without some type of CDN between the user and your server, you're using server components wrong. You're going to have a bad time. It's going to feel slow as shit, especially compared to a single page app. That's just first page load though. Where things get frustrating is when you start navigating. So if I go to /user info and then I change my mind or I click a link and I want to go to /dashboard, when I make that navigation, it now checks the CDN, see if that content exists. If it does, it sends it down. If it doesn't, again, round trip to the server before sending it to the user. That means you're no longer getting those instant navigations, right? This is where the nuance comes in. Kind of. I think React devs got a little too used to waiting for some data, showing a loading state while it's loading, and showing the result when it's done. And that pattern did work great for most of the apps that we built. It also means that everything that happens from here onwards kind of doesn't exist in the React developer's brain. This is a frustration I've had for a while. It feels like web devs don't understand servers, not necessarily as a generalization where like every web dev doesn't get it, but like my history is backend. And this is when I really feel like I'm not a traditional front-end dev as much as you guys stereotype me as one, because I very deeply understand this and have had to go as far as like explaining what cold starts are to Dan Abramov before, because not everyone gets it. And that's fine until you need to write code that runs on servers. And here's where the problems come in. I built us a mock app to try and showcase where things fall apart. This demo app is a dashboard. I'm going to open up the network tab so you guys can see what happens as we navigate around. I am going to click second page right now. and it loads almost immediately with no network requests. I'm going to click third page, and same deal, no network requests. Now I'm going to click first page. That took 576 milliseconds. It took way too long to respond. And if I go back, because Shane found the response time limit study, the barrier for feeling instant is 0.1 seconds. 1 second is above the limit for a user's flow of thought. So if it takes more than a second, then you've stopped thinking about the thing you're doing and your brain is starting to wander. 10 seconds, you lose their attention entirely. So ideally, you respond as close to 0.1 seconds or less as possible so that it feels instant. So there is nothing you have to do to handle the user behavior. If it takes longer, up to a second, then you need to be real careful to not lose the user's attention. And if it takes over 10 seconds, you're kind of fucked. So as we just saw on that page load, it took 600 milliseconds. It's not quite over the 1 second limit, but it's enough that it feels way slower. Because I click here, nothing. I click here, nothing. I click here, wait, then it shows. It sucks. Let's look at the code that causes this. I made a simple mock app here. We have the dashboard layout, has used path name, different links. Each of those links shows underline if you're on a certain page, or this outline there when you go to one. Not bad overall. But that loading time there, like watch, I'm clicking, moving the mouse, and it looks like nothing happened. It feels really bad. The reason that component is so slow, to be fair, is because I put a wait for 400 milliseconds there. I intentionally slowed it down because I'm fetching data from this like JSON blob locally. So it's going to be fast, but I wanted to make it feel slow because real API calls, real servers, real round trips, real distances between the user and the server, all of these things will make it actually close to 400 milliseconds. I've had services where the database calls can take multiple seconds, especially once the databases get big enough, things can get chaotic. People get really mad at me when I say database requests can take a second, and that's fine. It just kind of says they don't use real data. Anyways, the point here is that this one particular page takes 500 plus milliseconds to load and show to the user. The app structure here is pretty simple. We have the layout, which is the wrapper for the main dashboard page, as well as first, second, and third. These components aren't asynchronous, they're synchronous. And these components don't have any data fetching, nor do they have the dynamic flag at the top. I had to tell Next.js to force this page to be dynamic because by default, nothing was using cookies and nothing seemed user specific. So it had no reason to make this page dynamic. It would just build it at build time and serve it from the CDN. So if you're able to do that, if you can have pages like these two that don't have user-specific content, they don't need an auth wall, they don't need any of those things, you can just have it build out as static pages, and it's not even going to request them. When I click these are all content that was loaded in the JS bundle that now is there and ready to go when you click the links. That's really cool, in my opinion. The fact that once the page is loaded, once this whole site is loaded and the JS is there too, most of the pages aren't going to need extra work to get to. They don't need a network request. They don't need to do anything. They're static. Next.js knows that, and Next.js will load those pages immediately the way we expect with single-page apps, because RSCs are a true hybrid. It's SPAs when they can be, and MPAs when they should be. So how do we fix this awful loading time? I'm going to show you a build where I already fixed it, and then I'm going to show you how I did it. Watch what happens here when I click first page. I'm clicking it now. Oh, that was immediate. Why is that? That shouldn't have been immediate. Or refresh and try again. Clicking now. It showed me something instantaneously that time. If we clear this and you watch the network tab, I'm clicking now. The moment I click, we get that loading state. It wasn't a good loading state, but it was one. And that meant that most importantly, this sidebar where I click, as soon as I click, second page isn't highlighted anymore and first page is. That's a huge win for the expectation a user has when they navigate, that when they click, things happen immediately. But that was a server component. That was doing a bunch of complex server-side logic. The loading state must be complex too then, right? Because I'm not checking on the server and sending something down different when I'm loading. I'm not even doing prefetching here or any of those other hacks. So what's going on? Why is this so much better already? Well, I made one small, simple change. All I changed is I added this one file, loading TSX. In Next.js, this is the easiest way to add a loading state. There are other ways I could, in my layout, wrap a suspense tag around the children so that they don't have to be rendered before that content loads. But the loading TSX is the easiest way. In order to understand how loading TSX works, you need to understand a bit about the next rendering hierarchy. If I have a page like /dashboard/first, Next.js has to resolve this in a couple layers. First, we have the root layout, which is an app/layout TSX. That file is the one that has your metadata, usually for your main homepage on your site. It has your HTML tag, your body tag, any providers you might be wrapping your app with. All that goes here. This is the entry point for your app using app router and server components with Next.js. As we go through each of these steps, because our goal is to get to a specific file. The file that we want to get to, the one that matters, is app/dashboard/first/page.tsx. This is the one that has the actual content. But as we start from slash and go all the way to first, we're collecting things on the way. If we had an app/loading TSX, we would collect that at that point, but we don't. So what we do end up collecting is app/dashboard/layout TSX, then app/dashboard/loading TSX. What's happening here is as we go through the UI and as these components get mounted, this mounts as like the wrapper. So this whole section is app/layout TSX. Since that doesn't render any real content, the next layer is basically identical. I wish I had an easy way to indicate that here. Make it like slightly smaller, but know that this layer is still the same content HTML-wise. It's just a tag inside, but what you see as the user, it's identical. I almost want to sketch this out as HTML, actually. That might be easier. So the app layout covers all of this. Within here, we have that body tag. This is going to have the sidebar, and it's going to have the first page content. This section here, the content of body, is going to be wrapped with the next layout, and then this first page piece in there is one of the components being passed as a child. What matters about this is, as we go down the tree, we're looking to see what is or isn't static, and we're doing this during build. So at build time, we know that app dashboard first exists. So we're going down the path to get there and seeing what we hit along the way. What we notice when we hit first page specifically, since this component is dynamic, since this element requires something that is unique to this request, we can't generate this whole page statically. So what we then do is we climb up looking for a wrapper of some form. If I was to make this not HTML and make it the actual like names of the components, it might be a little easier to understand. App/layout is this root wrapper there. App layout has all of this stuff. In body, we have app/dashboard/layout. And then we have inside of the app dashboard layout component, the sidebar, because as we saw in here, that's what I mounted. I have div, class name, whatever, sidebar, and then this main element that has the actual content. We could even show that here. I then have main, and this is where children renders. So what happens if children has to do more stuff? Well, we'll go down the tree. App layout, static, cool. HTML, static, cool. Head, static, cool. Body, static, cool. App dashboard layout, static, cool. Sidebar, static, cool. Main, static, awesome. Children. Oh, children's dynamic. Shit. We need to find a way to render this page if we can. So the next step is we go up the chain looking for a barrier or a stop gap at some point that tells the build step, this can be static. So if we go back here, when I made this loading TSX, what this loading TSX does is it introduces one additional barrier. It introduces here app/dashboard/loading TSX. Now, when we are loading the dashboard right here, we can fall back to whatever's going on there. If you're familiar with suspense, you could effectively also put a suspense tag here to do the same thing. The point I am trying to make as I draw all of this out is that as you go down the tree, once you hit something that requires data from the server that's unique to the user's request, this whole tree can't be sent until all of it is generated. But if you put things like loading states above the dynamic content, or you wrap things in suspense, now we can build a version of this page. We can have a static HTML version of this page that doesn't include the children. It just puts the loading state in. And now when a user makes a request to go to the page, when they click the button, we can immediately show them that built, bundled, static version that is the loading state as we wait for the server to generate and send down the content to fill in to replace that loading state with. The reason that people are doing this wrong is that it's very different from how we did before. Previously, when we wrote a component, it was pretty simple. Here's a real traditional, basic, boring React component that we've all hopefully written something like before. In here, we have data, it is loading. We request the data. We check if it's loading still. If it is, we return the loading state, and if it's not, we return the data. This is great, simple, awesome. Also only works on client side. The problem here is that the data loading is now done entirely differently because we're doing it on a server-side async component. I can't go into first here and do something like, I don't know, instead of awaiting here, I can't return something different while this is going on and then return the rest later because functions don't work that way. React works that way, but functions don't. And once you're calling async functions, you can't send a response down and then send another one later. And that certainly won't work at the build step either, because we need to know what HTML each page points to. The only reason this model works for React as a single page app and as React that we know today is that all of this code, every single line of it, all of the functionality, all of the everything lives on the client. This code runs on the server. I'm hitting file system. So it doesn't even matter if theoretically I could return something different early and something else later, simply because this code can't run on the client. So the client won't know what to do with any of those different states as they happen. Thankfully, the React team accounted for this, as did the Next team. As a quick demo, I just replaced the loading TSX with this suspense fallback instead. There's a reason for this. When I go back to my page here and I refresh, you'll see we get the loading state and then we get the dashboard. If I go bump up the amount of time it takes, it'll be even easier to see. I'll make it 4 seconds instead of 400 milliseconds. So refresh, 1, 2, 3, 4, there we go. When I refresh again, 1, 2, 3, 4, cool. There is a catch though. I'm going to click on first page again. That's taking a while again. The reason is that the Next.js build step, the compiler that actually generates the pages that each of these things goes to in the JS that can navigate for you, isn't smart enough to know that that suspense tag we have here means it can generate up to this point as a static page. Next isn't smart enough to make a static page for this that is then bundled correctly. And that's why they introduced 2 patterns to solve this. The first one is partial pre-rendering, where it will go all the way down until it hits a suspense tag and then generate that as HTML. The other is one that I'm really excited about, dynamic I/O. These are not ready yet, so make sure you understand as I show these that they are very, very new. Server actions are not anymore. But if we hop in here, PPR true for partial pre-rendering and dynamic I/O true for these new I/O behaviors. I also have to go hop in here and delete this force dynamic. The thing that makes dynamic I/O cool is it's smart enough to look for the first async boundary and then treat that as dynamic. Dynamic I/O literally means on I/O, which is asynchronous work, things that hit file system, databases, network, stuff like that. At that point, opt into a better build step and loading pattern. So with that all on, if my understanding is correct, I'm going to restart the dev server to be sure. Reload. We get the loading state. Second page. First page. So really not smart enough to do that? That's annoying. I really thought that would be smart enough to handle this case. I guess it is not. If I build it, will it be? Loading dynamic I/O. If anybody at GitHub is watching this, I will do whatever I must to get you guys to change links that aren't to GitHub to be target blank. I should not click on a link and have it update and override the tab I am in. Clicking a link should open a new tab. This behavior has never once made sense. It never will make sense. Fucking fix it. I just built this with the suspense and dynamic I/O turned on to be sure. And sadly enough, now when I click first, still has the same problem. The reason for this is because layout doesn't rerun on client. This has to be run on server the first time. So when we're going down the path, this has to hit the server to run again because it knows that specific route is dynamic. So we need a way to tell it when that changes, and you can't do that in layout TSX. So let's move this suspense a little bit. Change this from the default async function to just be async function first page content. At the bottom here, export default function first page. Wrap that with a suspense. And now that we move the suspense there we go. Now we get those immediate behaviors. So the gotcha that I just hit, and I'll be honest, I wasn't sure if I would hit this or not. Part of why this is also confusing is if you're doing something asynchronous that requires data or is checking a user's information at any point during your render process, ideally, you show Next a clear path on how to get there statically. Since I moved that suspense here, the component first page, which is what gets thrown into layout TSX, that is static. So at build time, we can identify that this route is static up until the page loads this component, because then its child, first page content, that is now dynamic. And that will be fed in when it's ready. And the build step, the static HTML and JS that's generated for this route, will go up to here and will include this loading state instead. But as I was trying to hint at earlier, you don't have to do that, because all you have to do to get this behavior is add that loading TSX file. I don't know why my editor keeps doing that. Loading TSX. And now in here, if I export default loading, I don't have to worry about anything anywhere else. I just export that and I'm good to go. Since this is exported here, it automatically is inserted inside of the layout as the loading state wrapper. You shouldn't be doing dynamic stuff in layout if you don't have to, and you certainly shouldn't be doing loading data patterns in it if you can at all avoid it. The existence of loading TSX helps you shortcut all of this. And as silly as it might seem, we go back to the demo Dax had here. This absolutely could have been solved simply by adding a loading TSX file wherever the layout that shows these are. And it's annoying that you have to know that, but you also had to know that on the client side too. You had to know that when you get data, it has this loading state, and you have to return something for it there. The difference here is simply that we get type safety with all of these. So if you try to access data before you verified it exists, you get an error. So now we have to return the right thing before we can use that data. That's awesome. It's a really cool feature of TypeScript, and it's a big part of why I love it so much. There isn't really a similar way to do that type of type safety with these server to client interactions. There is no way for us to use TypeScript to check and say, oh, the component you just mounted is dynamic. Make sure there's a loading state somewhere above it so that we don't block the URL and we don't block the page. What I've considered doing is building a plugin for the next build step or lint step of some form that checks the outputs and makes sure that none of the routes that are built can't do these things. And thankfully, Vercel's given us relatively good tools for checking these. If I hop over to my inspector here, we can see what was built. And most importantly, at the bottom here, you can see what type of page each route routes to. The empty circle means static, so all of these pages are fully static routes. But then we have dashboard first, which is dynamic. They also have a cool partial pre-rendering indicator if you have that set up properly, where it'll be a half circle. We're not using PPR here. My ideal world would be one where when you have this and it's not on /API, you get an error of some form so the team can take a look and make sure that this should indeed be a function and not something static. You can also see here that each page gets its own JS, and we have this loading JS too. These all being embedded mean they're all on client, so when you click something, it can render the right content accordingly. Really nice having this output and seeing what is being generated. It would be much nicer if I could clearly indicate here that this does have a default state that it falls back to in the interim. And now we can see clearly here with the dashboard first that it's partial pre-rendered, which, as they say, means it has static HTML with dynamic server-streamed content. So the user on navigation can immediately see the static content and then also kick off the stream for whatever parts are unique to that page and that user. It's so nice. And I am very excited for this to become the default in Next.js. PPR was announced 2 years ago, roughly. When I talked to Vercel, they're still hesitant to tell me to recommend it and even hesitant to tell me to use it. But in a near, soon coming future, this will be what we want to do on all dynamic routes so that they all have some static HTML that they can immediately load and then bring in the dynamic part when it's ready. And this all results in our ultimate goal, which is user clicks link, immediately has something happen, and then when the output is ready, it shows it when it's ready. To go back to my long post here, there are important considerations to make, and I don't think modern web devs are equipped to have these considerations, because the intricate relationship between the server and the client is something that most people don't understand. Both the client-side people and the server-side people. I saw both making fools of themselves throughout this. The client-side people saying it was so much better when it was a single-page app. You're making everything harder for no reason and slower too. And the server-side people saying, just send HTML. Why would you send all these other things instead? Both sides are wrong here because client-side navigation is objectively better. It makes it way easier to hit these latency expectations that users have. It makes your apps feel significantly better. But on the other side, if you're doing 15 plus requests per navigation, you're now authing the user 15 times every time they click a button. It makes the backend characteristics much harder to get right and the performance expectations much harder to land. It makes the load to the complete page way slower. It's funny how a page taking 2 seconds to load is fine if you see something immediately, but a page taking 600 milliseconds sucks if you don't see an interaction immediately. Single page apps let you get that 4-second load time, but also that immediate response. Server-side rendering lets you get the optimal time to complete page at the cost of that loading state. RSCs are this magical in-between where you have the traditional client behavior and you have the server loading all of the dynamic stuff together as one. So to summarize, the world before RSCs looked something like this. If we have left to right, we'll say it takes 3 seconds to load this page. The traditional MPA, which is traditional server, assuming that the user is clicking on a link here. The traditional MPA isn't going to show anything until you get to the end of the load. But it can do that load really fast because it only has to request the data once. It only has to auth you as a user once. It doesn't have to wait for a component to load before loading the next data. It can just load everything at once. So page loaded. We'll say the page loaded completely. Assuming they made like optimal data queries, they fetched everything with a single SQL call. Say it took 0.7 seconds. If we take a traditional single page app, it will probably take a hell of a lot longer to actually load the content. And we can't say page loaded anymore because the page is always loaded. You're not loading a new page. So we'll say content fully loaded. The content fully loaded might take a lot longer. It might take 2.5 seconds, especially if you have a component render and then it mounts a component that then has to go get additional data. Then it mounts a component that's going to go get additional data. You get all of these waterfalls back and forth. The difference with a traditional single page app is when the user clicks, you can immediately do something different, as I've been saying this whole time. So the first response will happen significantly faster, like literally 0.05 seconds. So the user will see something way earlier. The page will finish way later. This still feels better than this does. As crazy as that might sound, I didn't believe it either, but I've seen it. I have built a lot of apps in all of these ways. Most users will perceive this site as faster. I know that because that is what happened with Ping. The Ping GG site is not fast. You saw how long it took for all that to pop in. If I hop over to my actual Ping dashboard and I'm signed in here, I'm going to click the dashboard button now. Instantly get a response, and then the rest has to flow in. There were points where info wasn't in a great state, and that next state, it would stay in that loading spinner for like 2+ seconds. That's not the case anymore because we optimized it, but it didn't matter because when you clicked a link, it would immediately go to the thing. If I click join room, immediately get a loading state. If I go back, we immediately go back to where we were because that's all cached. If I hit options, immediately loads the next page. Even if it shows that loading state, it doesn't matter because when I clicked, something happened instantaneously. That expectation is key. Oh, good context from Lee here. Part of the reason that partial pre-rendering isn't stable yet is some of the warts that I just stumbled onto in the video. They want to get the model right with use cache and dynamic IO before you can have a good time with partial pre-rendering. It's then a switch that you'll flip for faster initial time to first byte. Mostly agree. The piece that I think is more important than TTFB is immediate navigations. I want not just when a user types in the URL and hits enter to have that show something as quick as possible. What I really want is when they click a link once the site's loaded, that they don't have to wait before seeing something change. And right now, the loading TSX file helps a ton with this, but not quite enough if you don't know how to apply it properly. I really want a world where every click has that SPA magic of instantly showing you the next page in some state, even if it's entirely empty. But I want a reaction to my click immediately, then the data when it's ready. Yeah, the traditional SPA. Now I'm going to do something controversial. SPA dev building RSCs. So you take a single page app dev that is just not familiar with server load patterns or the nature of how RSCs work here. It'll be faster because if you took the exact same code with those nested components, doing the waterfalls on the server will be a hell of a lot faster than doing it on the client. It might even be like half as slow. We'll say that. It's possibly more, possibly less. We'll say half as bad. 1.2 seconds. This still sucks. This still is a really unpleasant experience. You get much closer to the traditional multi-page apps performance, and honestly, if you built these exactly the same, it would be identical. However, you also have the same problem that traditional MPAs have, which is that you don't get a response when you click. And that's, to go back to Dax's post, why this site felt slow. If you built this demo with traditional technologies like Laravel or Rails without any client-side JS, it would feel pretty much exactly as slow as this does, plus the cold start hits and potentially JavaScript being slower, but in the end, it's all data fetching. It won't matter. The point here is that this feels slow because each page navigation, each click requires the server to respond with some content. This is also why HTMX doesn't solve the problem. As much as I love HTMX, it doesn't solve this. But there is a win here. There is a way. And the way is what happens when a backend dev gets RSCs. When somebody actually understands these RSC patterns, or maybe they watch my videos and learn about it that way, or they've been paying attention to all the Vercel changelogs and release notes and all of that stuff, it is harder to get here than it should be. But once you are, you end up here with the best of all worlds. You get a first response just as quick as you do in a single page app, and you get a full content response roughly as quick, if not just as quick as you would in a traditional MPA. These two terms are usually TTFB, which is time to first byte, and FCP, which is full content paint. The problem with MPAs, as well as RSCs if you do them wrong, is it makes TTFB the same as FCP. If time to first byte is the same as first contentful paint, then you end up with that awful loading window up until then. I'm going to draw these in with two different colors. Red is for the bad loading state, which is the user is relying on the browser's loading to see that anything is happening. And with a traditional MPA, you get that state up until the page is loaded. With a traditional SPA, this loading state gets resolved almost immediately, and now you, the developer, can have a nicer loading state. We'll make it yellow. I was going to make it green, but I'm scared people will make that think it's good. It's still not good to be loading for this much time, but it's a hell of a lot less bad than being in the terrible browser state where it doesn't feel like anything happened. Problem here is this. And this is what Dax experienced. This is why it felt so bad. He was in the bad loading state the entire time until the response came through. In my opinion, the goal is get this red bar as close to 0 as possible and get the yellow bar to be as short as reasonable. In an ideal world, there would be no red bars and short yellow bars. And the option here that has the shortest red bar without massively increasing the yellow bar is definitely server components. Done right. If we took all of this and flipped it, you'll hopefully see what I mean. Ta-da. And we will say we screwed up moving all this JavaScript to the client. This is what they mean. The lowest number here by far is the multi-page app. It is the one that can load the content to the user the fastest because the request comes in, it immediately gets resolved with a specific page's content, and the user sees it when it's ready. But they get nothing until it's done. This line here is a good response time for when the user clicks, and the MPA doesn't hit it, and the server components without good loading behaviors also doesn't hit it. If RSCs are done right, it should get the best part of a single page app, as well as most of the performance characteristics we expect from multi-page apps without the negatives. It's kind of going for a best of both. And in my opinion, it does a very good job at it, as long as you know the quirks and gotchas. This is the easiest way I could summarize all of this, is this chart. The goal of RSCs is to take all these bad data loading patterns we use in single page apps and squash them into a much faster server-side on-request data load. And it does a great job at it if you know how to use them, and you take advantage of tools like the loading file, like suspense, and use them all properly and carefully. But if you don't use those things, you end up with a slightly worse version of what we're used to in the old multi-page app era. So you got to be careful when you use these things. Make sure you're putting loading places, or make sure you're putting loading states in all the places they make sense. It's really, really nice behaviors and characteristics overall. It's not a proper server component video if I don't talk about HTMX for a bit. So this is one last tangent, because I did mention HTMX in my post. What HTMX had to say is, most clicks on a web page do need to make at least one round trip to the server. I agree. When you navigate to a page, it will likely need some data that is from the server. The only thing I disagree with is this part. Is it really better UX to replace the browser's reliable, informative, batteries included loading bar with a spinner, assuming the dev even bothered to? Yes, it absolutely is. It is significantly better. And it sucks that this is the case, but the browser loading behaviors are shit. They are garbage. They are really genuinely bad. No one understands when the browser is loading something, they hit the button 4 times instead is what ends up happening. There's a reason that rage clicks are one of the most important things we track on our apps through our analytics tools and our error management tools. If the browser doesn't show you on click that something is happening, right where it happened, the locality of the response is important. If it's a bar at the top of the page, it doesn't matter. If it's a loading status at the bottom of the page in the bottom left corner, it doesn't matter. And it's sad that I am the only one who's like in between here, because as you guys know, HTMX was built by and for backend people, and it is so correct most of the time. And this is why I am regularly stuck in the middle, is I have to explain to front-end people why HTMX is good, but now I have to explain to the back-end people why the browser sucks. I'm stuck in these two places where I have to explain to React devs that not everything should be JSON, and I have to explain to HTMX devs client-side JavaScript for loading states is actually a beneficial thing. It's a good thing to not wait for the browser to decide what it will show you and when, to actually control that state. It makes things feel faster when you click and you immediately are somewhere else. Even if the page is empty, if I own the loading state, it does feel better. Browsers are incredible, but they're also terrible, and the user experience built into the browser by default is not a good one. We should stop pretending it is, because we will end up with many more slow sites, and it is this exact mindset that results in the problem that I was quote tweeting in the first place. If you think this way, all you're going to end up doing is building more terrible feeling sites like the one that started this video in the first place. We need to make things that feel good. Hopefully this was a useful deep dive onto the performance characteristics of different ways of rendering, and maybe, just maybe, a useful way to think about server components. Let me know what you guys think. Are RSCs way overrated, or is all this drama being a bit overblown? Let me know in the comments. And until next time, keep rendering.